have character variable, okay? And you can actually do subtractions or additions with all the characters, like this, right? So C minus A, if you look at here, it's going to be depending on what you are exporting, the format, specifier you are using, right? So if you look at C is OX63, right? And A is OX61. So if you print out that result as a hex number, you are getting 0, 2, right? Because the difference is 2. So it's going to be 0x02. Let's try it. If you print out the result as a character, it's going to be a different result. I'm going to show you in a bit. But now let's just try this. Okay. Just this one, okay? C minus A and printing out Y as a unsigned number, and you're expecting 2, right? 2. Okay? 2. No problem. However, if I do this, there's a 2-digit decimal digits difference. However, if I print out that difference as a character, which you're expecting, it's quite interesting. I just found out that this result, interesting result, a few days ago. Let me show you. Is that funny?
That's awesome. How does that work?
Yeah. It's a character. It's a character. Since you're printing out the result as a character, that's what you're getting.
Smiley face.
That's
Yeah.
0x02 is a smiley face.
Yeah, that's what you'll see here. You can try just print out 0x02. It's going to be the same result, right? Anyway, we're not using this for any of the embedded systems. It's not doing for any of the hardware, but just let you guys know what's going to happen. So the reason I'm going to talk about this is because in the lab 2 this week, okay, I'm not giving you a solution because it's just I leave all these important areas blank. So let me show you. Yeah, because in the lab, students were saying like just guessing or doesn't know anything, doesn't know where to get started. So here, so first you need a convert function, for example. Okay, so the convert function converts your letter input, like SOS, help, whatever letter input, into a row number, which is the entry of this lookup table. Everyone can build this in your code because it's provided. Part of it is provided on the website, right? If you see .-end, you can directly get everything done by yourself. So you have how many entries? 26 entries. How many columns? This is the array. It's a matrix. Okay. You have 26 entries, 26 rows, and a certain number of columns, which is changing, varying depending on which letter you are looking at. That's something you have to tackle in your code. But what's the longest? What's the longest row? 5, right? Yeah. It's going to be 0 to 4. Column 0 to column 4. And you can see at the end, it's always the same signal, which is end, END. Someone you got confused, like why these are English? Are they characters? What are these? Dot, dash, end. What are they?
Variables.
You define it.
Yeah, you define it.
Yeah.
Yeah, it's variables, right? You define it. It just represent single digits. Just a byte, right? Just a byte. Even though they have 3 characters in that name, just a name. It's a name. So dot is basically the name of 0. If you put a dot there, the compiler will treat it as 0, which is the 1 byte, right? Okay. Why do we want to use dot dash n, not 0, 0, 1, 2?
So the code's more readable?
Yeah, we're Americans, we understand English. I want to read English, it's more comfortable. So we know this is the dot. If you put a 1 here, what is it? Have to look up and see what is that, right? You have 3 variables. If you have 100, English is better compared to numbers, right? Okay. So you have all the names. It's actually 0, 1, and 2. And it always ends with 2. So even though they have varying length or different number of columns, but you know when it ends. That's where this is getting helpful. Because no matter which entry you get into, you can always try to detect number 2 to see if you are done. Okay? So what's going to happen is you convert that letter, could be SOS, one of them, the letter converted into a number. So where do you get that number? The convert function will do the job for you. Okay, and how? It's just simply convert function on the top. Okay? If you look at, assuming we are doing lowercase, okay? If you are looking at the ASCII code, okay? If I want to use 3 for D instead of 64. So I can directly use D character minus character A, like what I did in the beginning of the class, like this one. So C minus A is what? 2, right? C minus A is 2. So this will be 0, 1, 2. Okay, so this will be row 0, row 1, row 2, or entry 0, entry 1, entry 2 in the matrix. Why do we want to do that? Since the index starts from 0 for the entries. Let's look at it really quick. See, I have 26. You don't have to use 26. We want to use 26 because we know there are 26 letters. You could also use what? Whatever plus 61, right? It's just not that convenient. You can, it's just based on the baseline you are starting with. You can start with 61, which is A, or you can just treat A as 0. Treat A as 0 because A is basically at row 0. So all the other ones are just subtracting A from that number. For example, B. Which B is at for the which row is B at for the lookup table? Row 1, right? It's row 1. Is that row 1? Yeah, so row 1. So in that case, I just want to use whatever letter minus A to get that difference. So for example, B minus A is what? 1. So if I put that in, I'm basically getting row 1 for B. It's correct. What about A? A minus A is what? 0. So if I put A into here, the row number for A into it, it's row 0, which is exactly A. So that's letter A's Morse code. Dot dash, that's it. So now you know what you want to put in here. Convert the letter into a row number. So what is that code should be in that function? So here is carrying an argument, which is the letter itself. So the letter is a letter with is a character. Okay, so that character is a byte, which has a corresponding ASCII code. This is the argument you put into the function. It could be A, B, C, D. It's a character, okay? And that character has a ASCII code with it. So that's the argument you put into the convert function, right? See, it carrying that argument, which is the letter, into it, and you want to convert that letter into a row number for the lookup table here. So what's the code here should be?
Letter minus A.
Yeah, letter minus A. Whatever letter in there will be passed to the little equation, has that letter minus quote, single quote, A. And then you get a result. That result will be the row number. Or row index, not row number, I'm sorry, row index. Okay?
We want this integer to be a base 10, I assume, right? Not a hex.
Row number is decimal, since we're using 0 to 26. Yeah. So you can see here is unsigned 8-bit. Yeah, just use a decimal number. Should work, unsigned decimal. And this one, you have to return it. You have to return it because when you call this function, you want to return it to a variable, so you can hold that variable, hold that value in the variable. Do you know what I mean? So for example, your code, right? Okay, you're gonna return that result. For example, is I. You want to return it. So whenever you call this function, you just return it to another integer. Like this. So that function, which is here, will return it as an unsigned byte to this thing. So you can use it. So the value is stored in I, and you can use it. Okay? Definitely you are not putting this this line here. I'm just showing you how you want to call it. Okay? All right, so now you get a line index right now. You got a line index right now. So just imagine that there's a table, 2D table, okay? So what the code does is it searches really quickly whenever you have the row index, it directly get into that row and then scan every single column. Because every single column has a certain delay associated with it, like dash or dot or something else, right? Can you imagine that kind of action in your mind? So you just have to build that action in your mind when you are programming. It's a 2D array, it's like doing this, boom, first, right? Pick up that row. So it's not moving anymore because you have a certain I for that letter. It's directly jump to that row, and then you have to write a loop to do this, boom, 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 boom. Pick up every single one and do a certain delay, because every single one, a dot represent a delay. It's a dot delay. It's one time something, right? So whenever pick up, definitely 0 is just a name. It's not a delay. So you have to use the if statement, right? If the element I pick up from the table is a 0, if it's a 0, I'm gonna do a dot delay. Just put this one into the delay function. Make sense? So you're picking up every single Morse code and then convert it into a delay function. Okay, so see, for this function, the letter get into it, this argument, and being put into converter function, and immediately return I to you. So now you hold that I. So if I have S, what is the I if I have S? Let's take a look. 73, right, for S. A is what? 61. So you are getting 12. So I becomes 12. So it's gonna directly get into this row. All right. So now, here is a lookup table, has 2 indexes because it's 2D array. So index I will be the I you got for this convert function, and it's not changing. So you are looping, doing a for loop, but you can see I'm not looping I at all because I is just a certain entry. I already got there. So I have to loop through every single column for that row, for that entry, for different, for all the code, single code in that row. I mean, what I have here is different from Dr. Carlson's solution, but it works. So, for example, I start from column 0. That's why J start with 0, and then whenever it's smaller than 4, move to another column. So if that element is not 2, so what is 2?
End.
2 is end, right? 2 is end. Why? Because we have it here. 2 is end, right?
And you just put end in.
Yeah, put end in as well. Yeah, it works too. Yeah. If it's not end, then which means still in the middle, right? It's not reaching the end yet. Then do a if statement. If it's dot, do this. If it's dash, do this. Okay? I'll leave it blank for you guys to fill in.
Do you just upload this somewhere? Or
It's
this
already
is-
recorded.
Oh yeah. Okay.
Don't want to make it too easy. Yeah.
Oh,
Yeah.
gotcha. I was gonna ask the same thing.
Oh yeah, yeah, yeah.
Cool.
Cool. So,
And we're also able to use switch cases in embedded C.
yeah,
Okay.
if you want. All right. So if it's not end, do all these blinking or, the code beeping with the speaker. So else, what else covers?
When it is. Or any.
Either end or something else, right? What you want to put in there though? If it's end but it's not reaching 4 yet, what's gonna happen? You still want to stop it. You still want to stop it because it's right at the end of the column, the row, right? You think about it, what you want to do. So the goal is to stop this for loop. How do you stop it?
Break.
Could you? Try it. Who knows,
You could
right?
also just set J equals 4.
Yeah. Just directly put J to the maximum so it's not going back anymore. Okay? It's another way to do that. And then the main code, initialize it. I didn't change any other code. I think all the other ones are provided from the in-lab. I directly used it. So you can put the string, make sure it's a double quote sign there, not single. Single is for one single character and 2 is for a string. And you can assign it to array, string to array. And they're all characters. And if it's a string, it must be ended with null, which is /0, or null, N-U-L-L. If you print it as a character, it's gonna be nothing. If you print it as a number, it's gonna be 0, right? So that's null. Because every time you create a string in C, it will directly add a null at the end. I have to remember that. So for this string, how many bytes do you have for the string? 1, 2, 3, 4, the space bar, 5, 6, 7, 8, 9. The 9th one is the null, right? That's the end of the string. So the reason we have it is because whenever you are doing the scanning, whatever, you need a null to let them know that it's the end of the string. Nothing else after that. It's pretty much like the end over here, just an indicator, okay? Got it? So you are not creating null, but C will directly create it for you whenever you declare it. So there are 9 bytes. Okay, every character is a byte. So there are 9 bytes. And now this is whatever from his code, just press release to detect that press action. So if it's pressed, do what? That's the whole point, right? You press it.
Message.
So all the rest is just the initialization, and it's easy. Copied. I copied. She didn't write it. Oh, for here, it's a little bit different from whatever you see probably. That's what I did. So to delay for, is that 1 second?
Millisecond.
Oh, millisecond? Yeah, I just used a nested for loop. If this is 1 millisecond, then I'm doing 1,000 times 1 millisecond. It's giving you 1 second.
Yeah.
Oh, actually no. This is 1 microsecond. I forgot. Wait, which way? Either way. I forgot. Never mind. So it's gonna be you can do a nested for loop, because this will be if you put a number here, it's gonna do this number times 1,000, right? So that's how you can easily create multiple thousands of loops to waste the time over there to create the delay, time delay. I measure on the oscilloscope. I'm getting 5. I think 5 is for 1 microsecond or 1 millisecond. I forgot. Probably microsecond. 1 micro, whatever. So you can test it yourself. It's very easy to test, right? So just do the time delay and measure it. So these are initialization. I couldn't even remember it. So don't get scared. It's okay. The nice thing about MCC, I think, the PIC microcontroller, the company microchip, which the company updated everything. For example, the newest version, the version I used a long time ago, they didn't have that MCC function. So in the future, you create a project by clicking. There's a project automation or initialization, MCC, and it's going to generate a lot of header files and setup files for you, tons of them, which has like hundreds of lines of setups for all the registers. So how could you do that manually? See? So I think the PIC microcontrollers are doing an okay job now. It's just get you started as quick as you can. Even though still not as nice as Arduino's, because everything already set up. You just start with the loop function. You don't have to set up anything. If you want to really set up a register, you can still do it, but you are not required to do anything. So that's super fast, and this is okay. It's doable. You just have to know where to find all these setup functions, the registers, how to initialize it. These are from the data sheet. You find out the registers, put a 1, put a 0 in order to set a. See, you are setting this to run at 16 megahertz. Things like that. You just have to be very specific about all the parameters before you start running it. There's no default value for that. So now you press the button, you get into this code, right? Because we are trying to generate certain time delays for the speaker for that certain message. Okay, so whenever you press it, it should directly start reading that message, isn't it? So press the button because you are trying to convert the message into a Morse code, right? Let's just take one step back. Don't get scared or complicated. So let's just take one step back. What is the code does? It's actually really simple. You press the button. You start the whatever function of the code, right? So to convert that message into a Morse code. That's it. And the Morse code is nothing but just certain time delays for the speaker. Just time delays. So based on the letters in your message, and you just need a certain function to convert that letter into a certain time delay. And there are some like inter-word delays, inter-marker delays. It's just certain types of delays. It's okay. Let's don't get that deep for now. So press the button. It's gonna give you it's gonna convert letter by letter into time delays. So now you have to, if you press the button, you get into this part of the code. You have to find a way to take out every single letter. How do you take it out? Just use the index, right? Index.
Is space, what do we do for space? Is that just like a long delay?
Oh, it's a single quote with a space in the middle. Yeah. So the thing is,
For the Morse code, though, what are we supposed to do with the space? Is it just supposed to be an inner letter delay, or is it supposed to be a longer delay than that?
it's probably treated as a
It's probably
intra-word delay. It's a word pulse, because SOS is one word and help is another word, right? So should be a word pulse, which is like 7 times the time unit. 1.4 is 200 milliseconds for 1 unit. 7 times is going to be 1.4 seconds in the middle. Yeah, so you need an index. You can use for loop. You can use while loops. Probably while loops. So while it's not reaching the end yet, because I told you there's a null character here, right? So it's not reaching the end yet. Then go to the blink function here to convert it, because you know it's not null, right? Null is not doing anything. Null is just nothing. But if it's a letter, you have to get into one of the entries and do the certain delays. Okay, I'll let you guys put your while loop over here. Don't copy others' code, okay? I know there are several types of versions around, but since you guys are studying, try yourself first. And I think I already gave you a lot of hint. Any other questions? Okay. All right. So since we can add and subtract in between characters, and also definitely you can add and subtract numbers, integers with character as well. So if I have A to, let's change it to something else. If I have A assigned to Z, so Z is a character, represents A, and if I have Z plus 1, you can add a 1 to the character, right? So if you print out this one as a hex, are you getting a B or getting something else? So A plus 1, right? It's basically A plus 1. 62. No, OX62 actually, right? Something wrong? What did I miss? Oh. Six two, okay. How do you want to add 0x in front of it? Just a really simple question. But the person sign is gonna separate the main text from variables, right? So just to simply put a 0x over there. It's gonna print that 0x as a text instead of a variable, right? So the reason I have to run this is because in the future there are a lot of tasks regarding printing out texts in a certain pattern in embedded systems through the serial. After you learn UART, you have to do it. Oh, remember for lab 1, Dr. Carlson already coded everything into the hex file. You directly download the hex file into that demo. You run through like 10, 11 tasks. Every task is going to show a different text in there, right? It's really interesting because what he did is, the first lab, he lets you guys just try all the different functionalities of the board, the components of the board, and have something printed out to the serial monitor, PuTTY, right? PuTTY. And actually, in the following labs, every single lab is going to target every single component. So the first week, you know what's going on, but you didn't know how to do it. But for the following weeks, you just learn how to make everything happen. I think it's a pretty neat design. Okay, so you can x 0x as the text. Okay. What about this one? Let's change it to byte. Okay. This is part of the overflow issue. We have to know, especially for embedded. If you see a weird number, weird results, you should know why that happens. So count is a variable, right? So that variable is independent to the I increments. No matter what I is, no matter it's overflowing or staying within that range, it's gonna add 1 to itself, no matter what, right? But however, whenever the condition is not getting satisfied, it's gonna stop adding 1 to itself. So the condition statement is really weird because I initial value is 200, and whenever I is larger than 100, it's gonna add 1 to I. It's always larger than 100. 200 is always larger than 100. So what's gonna happen?
It's just gonna stay in there.
Stay in there or keep adding?
Keep it.
Because it satisfies, right?
Yeah.
So it's gonna get into the loop and adding 1 to count. So what's gonna happen eventually?
Memory over. No.
It's gonna add to a trillion, a million, and until it's run out of power for the laptop.
Yeah, you'll run out of memory. It would overflow back to 0 at
Yes.
some point.
Yes. So it only has 8 bits. So you won't be able to hold a trillion in there. So the largest number for 8 bits will be what? O1s, right? What is O1s for 8 bits? 255, right? So after 255, it's gonna roll over to 0, and start counting from 0 to. No, why?
It'll break them.
It has to be larger than 100 in order to keep adding, keep running, right?
But I count different.
But it's not getting into the loop at all. It's not even getting into the loop because 0 is smaller than 100, so it's not even getting into it. Does that make sense?
Yeah.
Am I losing anybody? Or everybody?
Interesting.
It's a really short code. Just take a look at it.
Yeah.
I don't plan on doing more, so relax. 10 minutes from now, we are going to break for a long weekend.
How was your day today, Doctor?
It's been great. I'll be on the road right after this.
Where are you going?
If you're okay, Durango, if you're okay, I will just go now. Just wrap up and go. I got a 6-hour trip.
What are your plans in Durango?
Oh, my kids, family, just
Fun times.
have 2 daughters, 7 and 9 years old.
Oh wow. I've got little siblings. One's 6, one's 5. So.
You know Bayfield?
Yes.
I'm from Bayfield.
Yeah, you?
Yeah.
Ooh, nice. All right, take a look at it. What's going on here? What's gonna happen? And let me know why. It's important because I think I was looking at the homework. You just have to know this in order to do the homework. But it's still last night, right? You already submitted. Good luck. I don't know how I did it anyway. So you know how that works, right? So 8 bits, they start from a 200 because it satisfies larger than 100 immediately. It's gonna get into the loop and adding 1 to count. Count starts from 0. It's gonna adding 1, 2, 3. So 200 because I will increment as well. So 200 after 200, you just treat 200 as 0 for now. Okay. So 200, 1, 2, which is 201, 202. Let's say 1, 2, 3, 4, 5 until what? 55. So whenever it reaches 55, 255, or let's say 55, what's next? So 255 is still,
Greater than 100.
yeah, a byte still able to handle 255, no problem. Okay. However, and also 255 is larger than 100. So still get into here and then add one more number to it. 56. So what is count?
56.
56. Did you get it?
Yeah.
Starting from 0, okay? Just count. 1, 2, 3, 4 until 55. You got 55 numbers, right? And still larger than 100. And still holding in 8 bits. Okay, it's gonna add one more. It's gonna flip. It's gonna clear out all the 8 bits and carry out. So because it's only holding 8 bits, so that carry out is not being held anywhere else. Not held anywhere else. So I have 8 zeros, and that number becomes 0. It's not satisfying this condition anymore. It's gonna stop. So we're getting 56 for count. Let's run it, and I'll let you go. Write.
You should have a print count.
Run it. 56. Have a great weekend.
Thank you, Professor. Have a good
Sure.
weekend.
Yeah, too.